All right, for this section, we're going to be doing 1-4. This is measuring angles, all right? So, an angle is formed by two rays with the same endpoint. So, if you remember from our last section, we talked about a ray going in one direction and then a ray here. That would be what makes an angle, is two rays that share the same endpoint, all right? The rays are the sides of the angles, and the endpoint is what we call the vertex. Now, that's very important to remember, to make sure that you know this point right here is our vertex. You'll need that when we go into naming them as well, okay? So, let's talk about how to name them. Look at the diagram over here to the right. It tells you that we have an angle here. There's a 1 on the inside. There's B, A, and C here. And we're going to use all that information to be able to name it. So the first thing that we can do is we can name this angle 1, all right? Whenever there's a number in there like that, that's not the measure of it, we can use that to be able to name it, all right? The second thing that we can do is, if it's only one angle like this, we can actually use just the vertex. And if you remember, the vertex is what we said was the end point. So that would be also where we could call it angle A, all right? The last one actually has two ways of naming it. The key is you have to use the vertex in the middle when you're naming it this way. So we can name it two ways. We could call it angle BAC, or we could call it angle CAB. Either one of those would work as long as A has to be in the center, because that is your vertex, all right? If you do not have the vertex in the center, you've named it wrong from the get-go, okay? All right. Of course, you have an interior and exterior angle, guys. The interior angle will always be what's inside of it here, and then your exterior would be everything that's on the outside. We'll get more into that when we start talking about parallel lines cut by a transversal, when we start talking about interior and exterior stuff. But you have the interior of an angle and an exterior angle right there, okay? All right. So what are two other names for angle 1? Well, guys, if you look, angle 1 is just this part, all right? So we cannot use the whole thing. We can only use what's given to us for that. Well, a lot of people would try to call this angle M. We can't do that, because angle M could be one of three angles. It could be this, it could be this, or lastly, it could be the entire angle. So we can't really use angle M, all right? But we can use the three letters that form it. So the first one that we could use is angle JMK, all right? Because those are the three that use it. And remember, the vertex has to be that middle letter. The second way that we can name it is angle KMJ, just reversing the order around, okay? Next up, we have our different types of angles. We have an acute angle. An acute angle are where they're smaller, okay? So the key is, whenever we do an acute angle, that X has to be less than 90 degrees, all right? Now, they throw in there the fact that it also has to be greater than 0, but we're not going to go too far into that one right now, okay? The next one we have is a right angle. This is where X equals exactly 90 degrees. A lot of people try to assume that if it's 90.1, it's still a right angle. It's not. It has to be 90, period, okay? Next up, we have obtuse. This is where you have to pay attention to two parts. First off, your X has to be greater than 90, but it also has to be less than 180. And that's how we would signify that, by putting the X in the middle with those symbols, saying that X is greater than 90, but it's also less than 180, okay? And then the last one is straight angle. That's where X equals exactly 180 degrees. And you'll notice that it makes a straight line. So that's where they get the name straight angle, okay? All right. What are the measures of angle LKN, JKL, and JKN? And then they want you to classify each one. The first angle we're going to talk about is angle LKN. Now, when we're doing this, if you can start at 0, it's always great to do that when we're talking about using a protractor, okay? And this is what we would call a protractor. It helps us measure angles, okay? So we're going to start at the one that has the 0, which is the inside track right here, all right? So when you see that, that means we're going to take it, we're going to go all the way around, and since it started at 0, we're going to end at 145 degrees. So the measure, and that's how we're going to represent the measure, so the measure of angle LKN is equal to 145 degrees. All right? Then we've got to do the same thing for our other two angles here. Let's start with, or let's do JKL next. So if I start at J, go down to K, and then go to L. Now, you'll notice with this one, it does not actually start at 0. So if we're trying to find the measure of angle JKL, we have to do a little bit of math here. With this one, we can use the inside or the outside track. It doesn't matter. If you notice, the smaller numbers are on the outside track, so it's a little bit easier to use those. So that's what I'm going to use. So we have one of them at 90, and we have one of them at 35, right? So what we're going to do is we're going to subtract those two things. If I do 90 minus 35, that tells me that that angle is exactly how many degrees? Well, that would give us 55 degrees. All right? Next up, we need to go ahead and find our last one here. If you want, you can go ahead and pause it and see if you can figure this one out yourself. But if you want to stay with us, you can go ahead and do it this way. We're going to find the measure of angle JKN. All right? JKN says we start at J, go down to K, go down to N. Now again, we see that we have a 0 here, so we're going to use that inside track. We follow it around to where we get there. We see that it is exactly 90 degrees. So when we're looking at all three answers, we get 145, 55, and 90 degrees. All right? Now, let's go through and classify these. If I'm doing the first one here, 145 would tell me that it is obtuse because it's greater than 90, but less than 180. And then if we go to 55, that's less than 90, so that would be acute. All right? And then, of course, our 90-degree angle for the last one here would just be a right angle. All right? Next, we're going to talk about some congruent angles. Congruent angles are angles that have the same measure. All right? This means that the measure of angle A is equal to the measure of angle B. Then we can also write it as angle A is congruent to angle B. So we got rid of the measure of to be able to do that. So if you write the measure of something, you should not have congruent. If you just write angle A is congruent to angle B, then you should have the congruent there, okay? Just like we did with segments, is we have to be able to mark it in the picture. If you notice right here, we have these little arcs in here. That tells us that they're congruent. If they have one mark in each, they're congruent. If it's 2 and 2, they're congruent. But if the marks do not match, then we cannot say that they are congruent at all. All right? So, let's use congruent angles. It says, synchronized swimmers form angles with their bodies, as shown in the photo. If the measure of angle GHJ equals 90, what is the measure of KLM? So they're telling us that GHJ, which is down here, is 90 degrees, right? You'll notice it has how many marks in it? 2. So we need to figure out what else has 2 marks in it. Well, they're asking us to find the measure of KLM, which is right here. Does it also have those 2 markings on the inside? Yeah. So we know, without a doubt in our mind, because of those markings, that the measure of angle KLM would also have to equal 90 degrees. All right? So you guys go ahead and pause it. Try the one at the bottom here, and then we'll be back in just 1 minute. Okay, so hopefully you had a chance to do that and you're back with us now. So for the measure of angle ABC, that would be this one. They're telling us that it is 49 degrees, all right? Once you do that, they want you to find the measure of angle DEF. Now, you should notice that they both have the one arc there. If they both have the same arc, then they are both equal, so we know without a doubt in our mind that the measure of angle DEF would also have to equal 49. Now, don't automatically assume every angle in this world is going to be equal if they ask it, because it's not going to be that way. It's just that's the way we're starting off right now, okay? So, go ahead and answer these 4 questions, pause it, and then we'll go on from there. All right, hopefully you're back with us now. Let's talk about angle CBJ. CBJ is this angle right here. It has 2 marks in it, right? We need to figure out what else has 2 markings in it. If you come over here, there's this one. There's a few ways you can name it. I'm only going to name it one way. I'm going to use the first 3 letters we come to, which would be angle GHF. Now remember, guys, you have to use that vertex as that middle letter. If you're not doing that, then it's not going to be counted correctly from here on out. The next one, F, J, and H, which would be right here. They want us to figure out which one's congruent. How many markings are in that? Well, you see that there's actually 3. And if you look on the other side of this, there's 3 markings right in that angle as well. Those are a specific type of angle that we're going to talk about here probably in the next lesson or so. But for right now, we're just going to call it angle AJB. All right? Now, you'll notice for this next part, they actually give us numbers. So we actually got to find the number that it would be. So they're telling us that EFD, which is right here, is 75 degrees, which has how many markings on it? 1. They want us to find the measure of JAB, which is right here. It also has 1 mark. Therefore, it would also be 75 degrees. All right? And then for our last question here, it says if the measure of GHF, which would be right over here, is 130, what is the measure of angle JBC, which is right here? The thing with that is it's also got the marking of 2, so it would also be 130, so your answer would be 130 degrees. Again, don't automatically assume every angle is equal. We just haven't learned any other options yet, okay? But guess what we're going to do right here? We are going to learn those other options. If you remember from the last section, we talked about the segment addition postulate. This is the same concept, but it deals with angles. We're going to talk about the angle addition postulate. What this is we're going to take 2 angles, add them together to equal 1 whole angle. So let's say that I told you that this is 50 and this is 40. Then you know that this whole angle would be 90 degrees. That's essentially all you're doing for this. But of course, as it is always in math, it's going to require a little bit more in the sense of algebra. All right? So if you look at the problem below, they've got our 2 measurements written in there. They've also tell us right here that the measure of angle RQT equals 155. What are the measures of RQS and TQS? So the first thing that we need to do, of course, is solve for our variable. They've already written in here the angle addition postulate in words. Then you'll see that we're going to do the substitution property. So RQS, if you look over here, RQS is 4x minus 20. So that's what I'm going to write in that spot. Plus TQS is right there. We're going to write 3x plus 14 in that spot. And then we know it equals RQT, which is 155 because it told us in the part above. Now, the next step is it tells us to go ahead and combine like terms. So 4x and 3x would give us 7x. And then we have a negative 20 plus 14 would give us a minus 6. And it still equals 155, right? So next step is we got to get rid of that minus 6. So it says it over there to the right. We're going to add 6 to both sides. So 7x equals 161. All right? Now, for our last step, we got to divide each side by 7. So if we divide each side by 7, that gives us that x equals 23. Now, again, a lot of students make this mistake. That's not the answer we are looking for because here in the words, it told us that it wanted the measure of RQS and the measure of TQS. So what you have to do is plug that in. So let's find RQS first. So if I'm finding the measure of angle RQS, I'm going to take 4 and then take that x out and put 23 in and then subtract 20. So when we do that, we get that the measure of RQS equals, we get that the measure of RQS equals 4 times 23, which is 92. 92 minus 20 would give us 72. All right? Now, we also got to solve for TQS. TQS is this angle over here. So if we want to find that, we need to go ahead and take 3, multiply it by 23 because that goes in for x, and then add 14. So if I take 3 and multiply it by 23, I get 69. And then if I add 14 to that, I get 83. Now, there's always an easy way to check your work. All you have to do is add the 72 and the 83 together, and we notice that it equals 155, so we know we have done this problem correctly. All right? Go ahead and pause it here. I want you guys to try this problem, and then once you're done, go ahead and hit play, and I'll show you how to solve it. All right, so hopefully you had a chance to do this problem. A lot of students get confused about this at first because they're like, oh, there's nothing that it says it adds up to equal. That's where you're wrong. Look right here. It says angle DEF is a straight angle. We went over this earlier. If it's a straight angle, it makes a straight line. Therefore, these two sections here, this one and this one, make a straight line, which means they add up to 180 degrees. So if I'm going to go in and solve this, I need to add them together. So 11x minus 12 plus 2x plus 10 equals 180. That's what we need to solve this problem. You needed to know that a straight angle equals 180. So the first step is, if we can combine like terms. We have 11x and 2x, which gives me a total of 13x. Then we have negative 12 plus 2, or plus 10, excuse me, gives us a plus 2 equals 180. So if I want to get rid of this 2 now, I need to subtract it, right? So I get 13x equals 178. Now the last step is we're going to take 178 and divide it by 13. Now if you do that, you'll notice it's a decimal. Now I do want to point out I did make one small mistake here. So if you look back, when I actually was right here, if you take a negative 12 plus 10, it would actually be a minus 2. That was my bad, rushing through it. And guys, this is why it's always good to double check. If you don't think that you're correct, double check it, make sure. So now we would get 13x, and then we would add the negative, or add 2 to both sides. Once you add 2, you would get 182. Now we can take 182, divide it by 13, and we actually get that x equals 14. Now, this goes to show not everybody is going to do it perfectly the first time through. So don't think that just because you make small mistakes that you're not good at it. Small mistakes happen. It's about learning from those mistakes, okay? So, if we need to find now the measure of angle DEC and CEF, right? So let's find the measure of angle DEC first. If we find the measure of angle DEC, we take 11, we're going to multiply that by 14 because that goes in for x, and then we're going to subtract 12. So if we do 11 times 14, we get 154 minus 12 gives us 142. All right. The next angle that we need to find is angle CEF. If I'm finding the measure of angle C, E, and F, then I need to take 2, multiply it by that same 14, and add 10 to it. So if we do that, we get 2 times 14 is 28, and 28 plus 10 is 38. Now, again, we always want to go through and double check our work. So, to be able to check it, we can just take the 142 and add 38 to it, and it should equal 180 because that's what a straight angle does. So, that is our section on angles. Hopefully you got a lot from it, and see you in class.